What happens when protective devices interrupt faults? Imagine a bustling city where everything runs smoothly, but suddenly, a storm causes a power outage. In electrical power systems, protective devices are like the city's emergency responders, ready to act when faults occur. These faults can happen for various reasons, such as short circuits, overloads, or ground faults. The main job of protective devices is to detect these issues and disconnect the faulty circuit from the rest of the system, ensuring safety and preventing damage. A typical protection system includes three key components: circuit interrupters, relays, and transducers. Circuit interrupters are devices designed to break the circuit when a fault is detected. Common types include fuses and circuit breakers. Fuses are often used in distribution systems and melt when the current exceeds a certain limit, interrupting the circuit. Circuit breakers are more versatile and can be used in both distribution and transmission systems. They work by opening their contacts to break the circuit. Relays serve as control devices that receive signals from transducers and send commands to circuit interrupters to open or close. They are essential for ensuring that the interruption process is initiated quickly and accurately. Transducers convert electrical quantities, like current or voltage, into signals that relays can understand. For fault detection, transducers often include current transformers that monitor the flow of current in the system. When a fault occurs, the process begins with detection. The transducer senses the fault and sends a signal to the relay, indicating that the current has exceeded safe limits or that there is an imbalance in the system. Next, the relay interprets this signal and decides whether to initiate the interruption process based on predetermined settings and the type of fault detected. Once the relay decides to interrupt the circuit, it sends a command to the circuit interrupter. For circuit breakers, this involves opening the contacts to break the circuit. In the case of fuses, the excessive current causes the fuse element to melt, thereby breaking the circuit. When a circuit breaker opens, an arc forms between the separating contacts. This arc must be quenched quickly to prevent damage to the breaker or the system. The quenching process involves cooling the arc to deionize the gas between the contacts, allowing the circuit to be safely opened. In practical applications, the interruption of faults is critical to prevent equipment damage and ensure safety. For example, in a residential setting, a ground fault interrupter can detect imbalances in current flow and quickly disconnect the circuit if a ground fault occurs, preventing electrical shock. In industrial settings, more sophisticated protection systems are used to minimize downtime and protect expensive equipment. These systems often include zone-selective interlocking, allowing for the isolation of faulted sections without affecting the rest of the system. Overall, when protective devices interrupt faults, they play a vital role in maintaining the reliability and safety of electrical power systems. By quickly detecting and responding to faults, these devices help to protect both people and equipment from potential harm.